Right, we've looked at a few videos now, the one with some basic encryption and decryption concepts, and then we've looked at shift algorithms, and then we looked at substitution ones, where essentially one letter is substituted for another, and that's the one we're going to work with. And then we came up with an algorithm how to come up with essentially because you said two master keys, in other words, one for that we can use for encryption and decryption purposes. So we looked at and generating them alphabetically. We did say that we're not at this stage going to take into account the punctuation characters. We could do that, but I'm going to leave that in so that we can add that into our algorithm. So essentially the approach that you would have is, if whatever your word or text, or can be any length, that you're looking for, is what is the procedure that we would follow. The procedure we would follow is, let's just say we want to translate the word IT or it. Okay, capital R, small t, something nice and short. Capital R, small t. Okay, it, not RT, but it. Okay, what we would do is we would say, right, take each character in there. Well, fortunately, there are only two characters, so we'll start with the first one. Okay, and where is the capital R? Is it in the first? Is it in S master 1 or is it in S master 2? Okay, you're probably shouting at me. There it is over there. And then we take the corresponding one. It's at the 26th position. So we will take the 26th position character at in the other one. Okay, and then small t, where's small t? I see big T, I don't see small t at this stage. There we go. Now that one is in the bottom one here at the 22nd position. So instead of writing down a T, we would write down a B. Okay, and that's the way that we approach. So what we're saying is our algorithm that we're going to follow is quite predictable. And let's have a look at the first. Okay, I have written this perhaps more in a Delphi sort of pseudocode rather than a strict algorithm. But the nice part about it is that you can add bits and pieces of the small Delphi that you want, and then the rest of it you write in pseudocode. In other words, I'll translate it as I go along. Because that's all programming is. It's a translation of an algorithm. That's all it is. And if you can't do the algorithm, you're not going to do the translation. Okay, so let's just say the word that I've got to process, the line that I must process, or the text that I must process is encrypt. Okay, with an exclamation mark on the end. We'll come to that a little bit later, because that's going to play a role. So my new string, the one that I want to create, in other words, what is the encrypted form of that string there? I'll start off with a blank string. And essentially I'm saying for every character in this line, in this text, the capital E, the N, okay, so I would count how many characters, 1, 2, 3, 4, 5, 6, 7, 8, I think I've got 8, somewhere around there. Okay, and we know that their functions like length and that, so you might have jumped ahead and said, okay, but I know how to do that, but let's just stick with the pseudocode. Okay, so we would get the character. So the first thing I would do is I would get this capital E. Okay, and is the character in S master 1? Capital E, capital E, capital E. Probably shouting at me already, I know. Capital E, probably should have looked this up before. There we go. It is. It's at the 21st position. Okay, so we don't take that one. We take what's at the corresponding one in the other one. It's an S. Okay, is it in master? Yes, it was. Okay, this position, it was at the 21st position. Okay, that capital S. Okay, and find the corresponding character, and the corresponding character was an S. Huh? Okay, a capital S as well. Okay, right. Obviously, what we would then do is then add it on to the new string. Okay, at this stage I can say S new string is equal to S new string plus that corresponding character that I've just found. But what happens, for example, when I get to the next character, because remember I'm going through each character, and I'm going to look for the small n the next time around. Okay, where is the small n? Okay, that's also in the first one. So I would have gone and looked up the corresponding character there. Would have been a W. Okay, then I would have gone to small c after that. Let's say, right, small c, where is small c? There's cap, there it is there. Okay, but now that's not in master 1, it's in master 2. So I need to have something provision, and it's probably going to be quite similar. Okay, in fact, almost identical. Okay, so I'm going to copy and paste because I'm a bit lazy to go and retype that all. Okay, because there's two possibilities. Okay, so we could say else. Okay, and I put in an else there, because the two possibilities is either in the first set or it's in the second set. Okay, we're talking about letters specifically. Else if the character is in S master 2, then okay, in other words, like the C over here that we found there, if it, then find its position in S master 2. Okay, it was at the, where was that small c again? At the second position, and find the corresponding one in S master 1. Okay, S master 1. Now I probably need to, okay, just to recap there, we've got the two master keys automatically set up for us. We've gone through and looked at the algorithm and the code for that, so that would be something that could perhaps happen in the beginning of your program, your system, or on request the person could generate new keys, because obviously it would be a good idea from an encryption point of view not to keep the same key. It's like keeping the same password all the time. It's the longer you keep it, the more vulnerable it is. And so what we said was the basic premise was for each character in our string that we're looking at, so ours one was a string called Encrypt, and it could be any length whatsoever. We would go through each character, and two things would, for now, one of two things would happen. We would either find it in S master 1, or we would find it in S master 2. Okay, and that's essentially what we've tested for so far. And in both cases, we would do a similar process, is that S master 1, if we found it at position 12, then we would take the 12th character in the corresponding one in position in S master 2. If we found it in X we needed to encrypt, then we would go to the 7th position here, find it and say, okay, then we translate that as a D. So we've got this going at the moment. We set our new string to be a blank string for every character in S line to process. That's Encrypt in this case. Get the character if it's in master 1, find its position in master 1, and get the corresponding character in S master 2. In other words, in the opposite one, if we could put it that way. Else, if the character is in S master 2, then get its position in S master 2 and find the corresponding character. Now you might be saying, well, if it's not in S master 1, then it has to be in S master 2, surely. I mean, because that's all it is the alphabet covered. Okay, and now it's coming back to this little issue we have with exclamation marks and spaces, for example. What do we do with them? Okay, basically 2 or 3 approaches that you can have, or 2 main ones. One is that you just leave them exactly as they are, which we're going to do in our particular example. Or, as we said, you could have actually added them into the original master when you split it up into 2 strings. We could have included not only letters, but we could have included question marks and quotation marks and all the expected punctuation marks that you might get. You just have to cover them all, because the person might use a hashtag, or they might use a star or something like that. So we've left them off, and we're going to say, right, well, I have in this case, it's going to be your choice. I'm going to add another option in here, because it's either in the first, it either was in the first master list, in which case I looked up in the second one, or it's in the second one and I looked up in the first one, or it's not on that list. So for example, if I got to the very last one here, Encrypt, I got here to Encrypt. There's no exclamation mark in the first one, and there's no exclamation mark in the second one. Okay, so I have to deal with that case. So if it's not in the first master and it's not in the second master, then I can say, right, well, what is the corresponding character? Okay, else, and I don't even really need to test anything, because if it's not the first 2, it has to be the third one, and that's the idea of this nested if. If it's not the first one or the second one, in other words, the else is in between, must be the third one. Okay, so if it's not the first 2 possibilities not true, it has to be the third one, or we know in this case it has to be the third one. Okay, so what is the character? Leave the character as is. Leave the character, transpose as is. In other words, exclamation marks will stay an exclamation mark in this particular version. Okay, right. Once we've gone through that whole process, in other words, if it's found the letter in the one list and looked up in the other, or it's looked it up in that list and found it in the other, or if it's found it in neither, we're leaving the character as is. Okay, and that's the end of our for loop, except what we need to do is we need to add that character on, because we found the corresponding character. Okay, in each of these cases we found it there. Okay, and we found it possibly, or we found it possibly there, or we're going to say we're going to leave it as it is. So my new string would simply become my new string, I would add it on. Okay, when we say add it on, we don't mean adding like mathematics, because it's text, and my new string is equal to the new string plus I'm going to call it character found now for whatever we wanted to call it. In other words, whatever we found there, or the original one that we left there. So okay, plus the original character. Okay, please note I'm not putting in quotes or anything. That's not Delphi there. That's just some pseudocode plus the original plus the new character. Let's call it the new character. Okay, which in some cases might be the old character. And that would be my algorithm to do the, okay, and please note that's for a line of text. Now we can expand this. If we can do it for one line, we can do it for 100 lines, 600 lines, we can do it for a book. It doesn't matter, because we've got the code. So if I wanted to read this text lines from a file, or in a memo, I had lots of text loaded into it, I could. It's not a problem. Delphi doesn't care how much data you give it, or computers don't, but this is the code that will go through it line by line. Okay, what I'm going to do next is just give the Delphi equivalent of that. Okay, but remember that you can make a decision about whether you want to include some of the I'm going to say aanhalingstekens, but to the special characters that are not alphabetic. But I would suggest you have this in as well, just in case the person puts in some weird symbol that you haven't thought about, like a, I don't know, like a little cuppy thing there or something like that. Okay, just in case. It's always a good idea in programming to cater for all the possible cases. So we've catered for all the letters. We haven't specifically catered for the known ones. Like the known non-alphabetical characters. I mean, we haven't done anything with digits either. Okay, if you want to, you could split the digits 0 to 9. There's 10 of them. You could do 0 to 4, 0, 1, 2, 3, 4 in the one group, and 5, 6, 7, 8, 9, 10 in the other group. So you can expand that string to make it as versatile. Just remember there has to be an even number there. It's the same number there as there has to be there, and they would be corresponding positions every time, so nothing's new there. Right, I'm going to come back and we'll just translate that a little bit into pseudocode, but essentially it's, again, you've got to go through this and do it manually and note the steps that you're doing. So you went for every character, because you need to, if somebody didn't know this code, you had a younger brother or sister, or an older brother or sister, and you had to say to them, how would you go about this? That's the steps that you would explain. You might explain it in more English or Afrikaans or isiXhosa or whatever you're explaining in, but essentially that would be the process, the algorithm or set of rules that you would be following. Okay.